Precision is of great importance in this modern world, and today we will learn exactly how we can use Wheatstone Bridge to make precise measurements. Let's start with the basic potential divider circuit. Here we have the job of measuring the value of the resistor Rs. Now, to measure the value of resistor Rs, we need to have the value of current and the value of voltage across the resistor measured. To measure the value of current, we can put a ammeter in series, and to measure the value of voltage across the resistor Rs, we can measure it through a voltmeter. Now, provided we get the value of voltage and the current through the circuit appropriately and measured correctly, we can find the value of Rs using this. In this equation, you can see that the value of resistor Rs depends on both Vs and Is. If we plot the value of Rs with changing value of Vs, we can see that there is a linear relationship. We can see that there is a linear relationship. On the other hand, if we plot the value of Rs with the value of current, we can see that it's inversely proportional and will have a parabolic relation. So the value of Vs is linearly related and the current is inversely related to the value of Rs. If we analyze the value of resistance versus the voltage across it, we can see at any point the there will be a slight margin of error in measurement always, because uh, we need to consider the internal resistance of the voltage sources, be it by battery or some other thing. So there are always slight margin of errors in measurements. Now, if we have a slight margin of error in the measurement of voltage, there will be a relatively slight margin of error in the measurement of resistance. But if we take the case of current, if we measure smaller values of resistance, we will have very less margin of error. So for large variations also, we will have very less error in the value of resistance. But for measuring large values of resistance, if there is a very slight error in the value of current, there will be a relatively large value of error. The error will be large in the resistance. So the value of resistance Rs is very much sensitive to the value of current. So to cater to solve this problem, we have the Wheatstone bridge. So let's see the basic working of Wheatstone bridge. We know that if the Wheatstone bridge is balanced, the voltage across these two terminals, let's have a voltmeter across it and let's name it VA and VB. So these two terminals will have zero voltage across it when the bridge is balanced. What do we mean by balancing? R1 by R2 should be equals R4 by Rs. In here, the test resistance or the resistance which we want to measure is Rs, and R4 is a variable resistor. We will see why we have a variable resistor. So both R1 and R2 are fixed resistors of known value and of very precisely calculated value. And R4 is also a rheostat which has very precise moment. So we can measure the value of R4 very accurately. Now comes the value to be measured, which is Rs. The procedure that we follow to measure the value of Rs through Wheatstone bridges, we have firstly we have R1 and R2 are fixed resistors. Now we change R4 in accordingly till we get a voltage of 0 on the uh, on the voltmeter. So we change the value of resistance like this. We can move the knob either to the right or to the left till the value is 0 on the voltmeter. Whenever the value of is 0 on the voltmeter, we will take appropriate reading of the value of R4. Then we will find the value of Rs to be R1 over R2 into 1 by R4. So this is the value of RS. We see that here we don't need to measure any voltage or current through it, and the voltage the value of RS is very accurate. Now, apart from being accurate and not depending on other values, it is also uh, capable of removing the noise from the source. So we know perfectly DC sources doesn't exist. So there might be some normal DC sources which you use through the signal generator. They are driven primarily by AC and are then passed through a rectifier unit, which converts it to changing or rippling DC, and then it is passed through a filter which approximately gives out a DC signal. But there might be some noise in the while the signal is being processed. This type of measurement is called a differential measurement. So you can see that the left part of the circuit, let me just figure it out. You can see that the left part, I'm drawing it roughly. This is R1, this is R2. We had here the variable resistor R4, and here was the resistor which we wanted to measure. So we can see here that both the branches, the left branch and the right branch, are parallel to the source. So both will have the same noise. And how we are measuring the voltage Vs, it is the difference between the difference between the voltages Va and Vb. So both if there is any noise in the source through the source, both Va plus some noise minus some Vb plus some noise. So the this is the actual component, this is the noise component. I am dividing it to it. If we measure it, if we solve it, we get that both the noise components get cancelled and we get accurate measurements. So the another advantage of using Wheatstone is there will be very less noise, and the value of measurement or the value of resistance RS which we measure will be very accurate. Thank you.